Okay, um, we're working on reducing the rate of refusals. Oops, in a telephone survey. Most people who answer at all listen to the interviewer's introductory remarks and then decide whether to continue. One study made telephone calls to randomly selected households to ask opinions about the next election. In some calls, the interviewer gave her name. In others, she identified the university she was representing, and in others, she identified both. So we got identified the name, others the university, and in others both. The study recorded what percent of each group the interviewers were completed. Okay, is this an observational study or an experiment? So the first question is, was there a treatment imposed? And the answer is yes. The treatment was, what information did you called the person, what information did you give the person? Their name, the university, or both? And then the response variable is, was the interview completed? So the experiment you're really doing here is you give your name to some, you give the university to others, and to others you give the name and the university. And then you're comparing who were the interviews completed. Okay, and did it say we need to be a good experiment? We obviously want to make sure that those are randomly selected. It just says in some calls, so we have to make that assumption that they were randomly chosen. There we go. So this is the response variable. Was the interview completed? And the explanatory variable would be what information are you giving the person that you're interviewing? Okay, am I giving them my name, the university, or both? Okay, does that make sense? Alrighty, let's actually go to the next one. We can get a couple on here. Okay, 33, getting teachers to come to school. Elementary schools in rural India are usually small, with a single teacher. Teachers often fail to show up for work. Here's an idea for improving attendance. Give the teacher a camera with tamper-proof time and date, and ask a student to take a photo of the teacher. So you're giving the teacher a camera, then asking the teacher to give the student the camera to take a photo of the teacher and class at the beginning of the day and at the end of the day. Offer the teacher better pay for good attendance. Okay, verified by the photos. Will this work? A randomized comparative experiment started with 120 rural schools in Rajasthan, I think is how you say that, and assigned 60 to this treatment and 60 to a control group. Random checks for teachers' attendance showed that 21% in the treatment group were absent and 42 in the control group. Outline the design. Okay, so my outline, let's do it like this. Would go something like this. I've got 120 teachers or schools. And we got 60 schools were randomly assigned. To the treatment group. So I got 60 up here. 60 I'm given the treatment, which were digital cameras. And then 60 were given the control. Okay, so no cameras, nothing. Okay, so they don't know anything about what's going on here. And then we compared attendance rates. Now you might ask, why do we need to have a control group? Well, we have to have a control group because that takes into account other outside factors. If they were, say, like the weather, if there was a bad weather thing going on and teachers had to stay home to take care of their houses or whatever, well, that's going to affect both groups evenly. So that effectively evens out that variable between the two groups, so it won't affect the treatment group differently than the non-treatment group. So we want to make it so that the only difference between these two groups is in fact the treatment. So when it says 42% in the control group were absent and 21% in the treatment group were absent, we should be able to attribute that to the treatment only. Okay? So B, list the schools and choose the first 10 schools for the treatment group. Use table B 108. So the first 10 schools out of 120. So since it's 120, I'm going to have to label them 001, 002, 003, all the way up to 120. I have to use 3 digits because I go up to 120 schools, right? That way every school has a 3-digit number. So I'm going to jump over to my random digit table. Oops. I'm going to go back up. Oh, sorry about that. To see how many, line 108. So, see if I can locate my digit table there. There we go. So I'm going to zoom in here. Line 108. Oops. Sorry. Line 108. Okay, and remember my numbers. It starts with 001, 002, all the way up to 120. Okay, so anything above 120 I'm going to skip because those don't represent any schools. So I've got, oops, get that out of there. 609 is no-go. 407 is a no-go. 2202, nope. 417, nope. 868, 249, 436, 179, 090, 656, 879, 641, 883. So going through that whole first row, I haven't hit any 3-digit schools that are in that range. So I wrap around to 109, 360, 091. There's my first school that was randomly selected. Okay, that was 091. Next one, we'll do one more. 936, 515, 412, 396, 388, 545, 346, 816, 834. See where I'm going with this? 851, 197, 981. Now I'm wrapped around here. 486, 694, 876, and 051. Assuming I didn't mess up, that would be my second school. Okay? So we're just rolling through here trying to hit 3-digit numbers all the way, and I would keep going until I get 10 of them if I wanted to truly get a sample of 10. Now you don't have to go through and get all 10. I just want to make sure that you're very clear on the process. Okay? There you go on that guy. Let's look at 34. Okay, and 34 says the following. How does, actually, you know what, I'm going to cut this one off and I'll pick it up on a new one because this video is getting kind of long.